Algebra 2, Lesson 118. Jayla and Lydia, I want to show you something exciting. Look at our check sheet. Remember, I sign mine off when I have taught the lesson. So mine looks a little different than yours, probably. I've been circling the videos. Actually, I should have circled up in there too, but that's okay. That's not what I want to show you. Today is Wednesday. I'm going to prepare these 3 videos for you to do over the weekend. So that's the end of this week. We only have 1 more week of new lessons, you guys. I just want you to wrap your little heads around that. And while I have, like that, I just meant wrap your head around that. And while I have talked about prepare for AccuPlacers or any other tests you might have to take, I have no idea if those tests are even available or what's happening with the lockdown in terms of preparing for next year's classes, like at Running Start or whatever. And I know, Lydia, you're in process. You don't know what from the Philippines, blah, blah, blah. But my point is, Jayla, you probably should have your mom check at either Edmonds Heights to find out what's going on with Running Start for next year. When can you apply? Is that even what you're still planning to do? But we may not be doing, you guys might not be doing any testing in May, and therefore there's nothing for us to prepare for. So when we finish this on May 6th, final exam, we just may be straight done, which is a pretty cool and amazing thing to think about. Please keep in mind for the rest of your life, if you're ever taking any kind of math placement test or any kind of math that's in your life, and you want some support, reach out to me. I will help you. I have helped students do all kinds of additional testing and stuff like that. So this is not an offer of help. Whenever you get to the point in your life that you tests, holler, and I can help you prepare for that. But I just wanted you to see that you don't have to hold on much longer, you guys. Just dig in another 2 weeks and we will be done with the material. Okay, lesson 118 is an extension of what we are about logarithms. And I'm going to review everything that I told you about logarithms before, because I know they're confusing and difficult to wrap your mind around. Logarithmic, even the word is kind of scary and weird, isn't it? Logarithmic equations is going to be the topic of this lesson. Excuse me. My brain got distracted. Most students find this to be a little bit more manageable because instead of just pure calculation like we were doing last time with all those confusing buttons on the calculator, this time we're not going to need the calculators because we're going to focus on the algebra of logarithms, and we're going to play with equations and figure out how we can reshape them and simplify them and solve them. Most students find this much easier to wrap their heads around than the weird anti-log solving thing we were doing last time. But let me just remind you of how that looked. Last time I presented it, I put logarithms here and exponents here, I think, on the paper. I'm going to reverse that this time. And I'm going to start with something that will look familiar to you. 10 to the 3rd power equals 1,000. Okay, that makes sense. We know that's right. We know that when we, just as a simple reminder of how this works, we know that we take the exponent that's on a power of 10, and we know that's how many zeros should be after the 1 in the final number. So there's the 1 and then the 1, 2, 3. Okay, that's good. We have names for these things. This we call the base. It's the number that's being multiplied by itself 3 times in this case. This little pup is called the exponent, or the power. We can use either expression or word. And this, for lack of a better name, we're just calling it the number, right? It's It's what you get. It's the answer. It's what you get when you take the base of 10 and raise it to the third power. You get a number that is 1,000. Okay, logarithms show this very same set of three numbers. There's just a slightly different presentation to it. The log of 10 to the third power equals 1,000. Here's our base. And we also have talked about the fact that when we're using base 10, which is the most common base, many mathematicians will just drop that out and not even write it. Just like when we use radical signs, and when we want it to be to the root, the power of 2, we don't even have to write it there. That's like the norm. That's the same rule that's going into, it's the same shorthand that we're using here. If it just says log, then it's log 10. You don't have to worry about it. Okay, that's the base, just like this is the base. This is the exponent that sits on the base. We also call it log, or that's where it starts to feel weird. What the heck? We're calling exponents logs. That just seems strange. I always imagine like a log of firewood, you know, that you'd hit someone over the head with. I don't know. That just gets weird to me. Log seems really weird. This gets even weirder though. This is the number, right? This is what you get when you put this exponent on this base and calculate. But now we're calling it the anti-log. What? I know, I'm sorry. And what we found is that if you have any two of these three pieces of information, you can use the calculator to crank it through. We can also do the same over here, right? And let me get my little calculator out. Here's my fake calculator, you guys. It's really high tech, isn't it? And we have these 4 buttons on the calculator. And ignore these for right now. This is the button we use when we know the base and the exponent. We can enter the exponent in for the x. And we want the number. This is when we have the number and the base, and we want the exponent, right? So this little chart, man, this is one of the hardest parts of the button. Trying to figure out what do I have and what do I want. But the calculator can work in base 10 for us automatically. It's set up to do that. The other thing the calculator is set up to do is work in this base of e. And remember, e is about equal to 2.718, I believe is where it rounds. And it's called, because this base is super useful in the sciences and in engineering. If you're calculating, you know, stress loads on a bridge or something like that, I'm told that base that you use, and it just is a number that goes into this base position, but we substitute, we symbolize using this letter instead of writing out this number. Would this be easier for students to grasp if instead of naming it E, we just said 2.71878, blah, 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 or whatever it is? Probably. Well, I don't know why we throw the letter in there, but it's like pi, right? Where it takes a kooky, irrational number and gives it just a nice, simple name. So the important thing to know is that the calculations work exactly the same when you're dealing with E, and your calculator is set up with buttons to do the calculations in the base of E as well as the base of 10. And these mean the same, these mean the same. Now again, this gets confusing because what the heck? Why is it LN? Well, I don't know if this is exactly how this abbreviation was derived, but you can remember we call this the natural log. Log natural, right? I always use a loopy lowercase cursive L, so that, because this to me looks like one N, and that just gets confusing. So I always write it like this, LN. I just remember it that way. Natural log, log natural, right? Again, I'm not sure that's how it was derived. I don't know that story, but it's a really nice way to remember, oh yeah, LN represents the natural log, which is E, because it's used in nature. That's why we call it the natural log. Okay, so this is what we talked about last time. We used these buttons to calculate either the number, the antilog, or the exponent, the log, okay? If you're confused on which buttons to use when, welcome to the human race. You're a normal person. It's confusing. It takes a while to get used to it. I suggest that you create something like this. I don't call these sorts of things cheat sheets. I call them data pages. It's data that you need in order to solve the problem. So make sure this gets copied into the front of your notebook or wherever you keep super important math facts. If you write them in your book and then you save at least your last book for future math classes, you're going to have a treasure trove of formulas at your fingertips. Okay, so this is how we do the calculations. We were working only in the base of 10 or the base of e, the natural log, last time, because that's what our calculator is. This time, when we get into the algebra, we're going to be able to use random bases because we're not using the calculator. So when you see some weird bases come up in our new problems, don't panic. What you can always remember is that when we use bases other than 10 or e, it's a pretty good hint that we're just doing algebra, we're not using the calculator. Okay, fabulous. So we're just recapping what we know, and now I want to make a cool chart. You guys, this is like, to me, the culmination of all my work with my students over several years. And I'm always happy when we get to this stage. You remember our rules for exponents. You guys have both only had me for 1 year of algebra. Just imagine if you had me for 2 or 3, and we had talked about these dang rules for exponents endlessly over the course of those years. There are 3 of them. We've got the product rule, and we've got the quotient rule, and we've got the power rule. Okay, so far this is all review. New stuff is going to come in, and I am saving that column for last. Okay. Product rule tells us that if we're multiplying 2 expressions that have matching bases, we can just add the exponents, right? And if we're dividing matching bases that each have exponents, we can subtract the base, the bottom base from the top base, right? This is all review. This is what you know. And if we're taking a base and we're raising it to a higher power, that's when we multiply, right? Okay, this we've been doing for a long time. This you have seen multiple times. You've used these rules endlessly. So that is nothing new to you. Now, what's cool is that just like we could take this exponent information and rewrite it in logarithmic form, we can take these rules for exponents and rewrite them ever so slightly, although it might look weird at first, and we'll see that that logarithms behave exactly the way they behave in the rules for exponents. Now, I find this amusing. They're rules for exponent, but when you talk about them in terms of logs, they're laws. Whoa. That sounds so legitimately scary, doesn't it? Okay. I'm going to write it down, and then we'll talk about how it looks the same. All right, if we're these are matching bases, it's base 10, we don't see that. If we're multiplying these parts, then we can add them. And just like with our rules for exponents, we can take this law in either direction. Don't worry too much about what these mean right now. In a minute, we're going to be doing problems, and you'll see how we can put them to use. So right now, just notice that, oh yeah, okay, when we're multiplying, we add. When we're dividing, guess what we do? Subtract. And this is the one that looks the most different, but don't let it freak you out. It's really, I think, the most fun to use. Okay, so multiplication is linked with addition, division is linked with subtraction, and when we're taking an exponent and raising it to a higher power, what we do is we take that power and we jump it down in front of the log and then multiply it across. So there's the multiplication that we see here. It looks a little different in this form, but this one is the most fun to use. So these laws of logarithms match to the rules of exponents, and they allow us to do algebra on logarithmic equations. We don't need our calculators. It's kind of fun. Are you ready? Here we go. This whole page gets a puffy cloud of knowledge around it, by the way. I don't have room to do that. But it's true. You can do it if you want. All right. Now, the one other thing that I want to tell you, it's just a vocabulary issue. Let's just write down a couple examples here. This is another vocabulary issue that can make students' heads go a little blurry. When we write a logarithmic expression, we know the base must be 10 because it's not written by any of these, so we assume it to be a 10. And we know that this part is the exponent, right? Back over here, right? The number that comes after the word log is the exponent, right? Okay. We can also call, and I've underlined, call that argument. Whoa, that's weird. So that's another way to talk about the exponent, okay? It's what comes after the word log, and then the little base, if you happen to have that. Sometimes it's in parentheses, sometimes it's not. Sometimes it's a plain number, sometimes it's an algebraic expression. So if you hear me use this word, or if you see it in John's work, you know what it means. All right, now we're ready to do, that's like the longest preamble ever, isn't it? All right, solve. Writing. Okay, there we have an expression. As you look at this, you might begin to panic when you see that base of 3. Base 3, we don't know how to work in base 3. We don't have calculator buttons for base 3. But that's a really nice reminder to you that we're not going to need the calculator, and we're not going to be actually solving for a number. What we're going to be doing is using algebra and our laws of logarithms to simplify this, and we're going to solve for this x. That's what we're working to do here. Okay, now we know that if we can get this equation, oh, my pen is getting close to the end. If we can get this equation in an expression where we have 1 log 3 term on one side and 1 log 3 term on the other side, then we can take whatever the argument is. I've just drawn a box for the argument. We can just take those two things and set them equal to each other. Those aren't zeros, they're just like goose eggs. So that's our goal. This side is all set, right? We've got log 320 over this side is the single term. We need to find a way, a tool, to smush those together, the two arguments into one expression, then we're good. And if you look back to our cool laws of logarithms, we see it's right here. If you're adding them, you can multiply the arguments. Ah, okay, so that means we can say, there's one argument, there's the other argument, so we're adding them so we can multiply them, and we can write that like this. Okay, and then we have the other side. Right? Oh, my pen is officially going down the tubes. All right, so it's as simple as that. We just take the two arguments, multiply them together in a single expression. And that's using, let me just show you again, that's using our product law of logarithms. Or we can use them in either direction. This time we've got this and we're moving that way. Yay, it's not. So now, all we need to do is, we can even lift them in this form. Right now we're ready to do this. We've got single expressions that are equal to each other, so we just lift the arguments, and we can say x plus 7 times 2 equals 20. And now, basic algebra, ladies and gentlemen. There's no gentlemen. 2x plus 14, I'm changing the order, equals 20. I'm officially going to grab another pen. I can't get through that problem. We just do basic algebra on this, and we get 2x equals 6, divide by 2, and we get x equals 3, and that's our final answer. Okay? No calculator buttons, no calculating in base 3, all that is important to us is just showing that they match, and we've now solved an algebra problem using logs. And I personally find these much more breathable, don't you? Let's try another one. Copying. Log 14. What in the world? It's plus 3. Okay, the bases are weird, but they all match. That's important. They need to match. I don't think John throws us any curveballs with that. So log 14, embrace it. Can't hurt us. All that means is we know right away we're not going to use this on the calculator. And we see this one has subtraction, so we know, okay, that must mean this one, right? There's the only subtraction. So that means what we can do is we can take the arguments and we can rewrite them as a fraction. So we'll have log 14, and then this one will be on the top, and this one will be on the bottom. Okay, the other side stays the same. Now that we've got single terms, we can take the arguments off, right? We're at this stage. So we can say, I'm going to flip this, I'll just write it here, x plus 3 over x minus 3 equals 7. Right? Okay, here we go. Flip x plus 3 over x minus 3 equals 7. I'm going to put it over 1. Let's cross multiply. That gets us to x plus 3 equals 7 times x minus 3. Right? We just cross multiply. Now we'll distribute. Okay, let's swim the x's this way, and then add the 21. And we get 6x equals 24. You're gone, you're gone. Yay! Whoops, I'm dividing by 4, not x. Sorry, I got so excited. 24 divided by, now see what I did? I took the answer and divided by that. I'm getting too excited by these problems. We want to divide by 6. X equals 4. That's the right answer. My hand was cheating over here. All right, so there's using the quotient rule in it's the quotient law, right? Because okay, and so guess what the third problem is going to be? You're right. Solve. Copying. Okay, this one makes us even more nervous because it's got a log of b. It's got a letter for a base. Guess what? We don't care as long as we can take the two arguments off, right? Ugh, my hand is being so disobedient today. Log q, and then here's the first argument, equals log q, and here's the second argument. We can just pull the two arguments off, right? I don't know why I always just use this circle, but I'm showing that the argument can be anything. As long as it's in a simple expression, we can lift it off. This is not good enough because we've got this 3 out here that we're multiplying. So, let me go back to my chart. We go, that looks familiar. When you have the number out in front, oh yeah, you can take it and jump it up as an exponent to the argument, or if it's already up there, you can jump it back off, right? Either way. We would like to get it back up here. So we're going to rewrite this as log b x to the third equals log b 64. And now we're in this format. Now we can pull the two arguments off. X to the third equals 64. We take the cube root of both sides, and we know that x must equal 4, because 4 cubed is 64, right? 4 times 4 is 16. 16 times the third 4 gives us the 64. Yay! These are logarithmic equations, and when we use these nifty cool laws for logarithms, they make a lot more sense. This will also help you remember how all of this works, because we're using it in a different context, and sometimes that just makes your brain feel happier. That's lesson 118. Let me know specifically, after you have done the practice problems for lesson 18, shoot me a text and say either my brain is going to explode or I think I may survive these logarithms. All right, let me know how it feels after you've had a chance to do the 3 practice problems. I would like you to do all 3 because one's product, one's quotient, and one's power rule. So do all 3 of the practice problems. Practice problems for 118. Okay, I want you to have a chance to practice all 3. Okay, yay, we're done. Bye.